Homework Hotline, what is your emergency?
All right, hold on just a second. Before we start anything with the show, I have to say welcome back, Sam. And I'm not just saying this because it's written on the script here, we really missed you last week.
Thanks.
And not just because our eyes went a little crazy solving math problems for the entire show.
Yeah, I bet that was a little bit rough. Not that you guys did do a great job with it, just a lot of work. Thank you, Becca. Thank you, Nathan. Glad to know I was missed. Hello, everyone. You're watching the Homework Hotline. We're here live every Tuesday and Wednesday from 4:30 p.m. to 5:30 p.m. To help you with your homework questions.
So if you call us, we'll interact with you and walk you through your problem. Calling is really the best way to get your question answered. Our number's up on the screen, 720-424-1666.
We also have a few ways you can watch us live. That's on Comcast Channel 22, Prism TV Channel 8007, YouTube Live at Denver DPS TV, Facebook Live at EG Homework, or live stream at livestream.com. Just search for DPS TV.
So we're here to help you with math and science. The two of us can help you with math. Over there is Sam, and he can help you with science. We both teach at Emily Griffith High School, and Sam teaches at Contemporary Learning Academy.
And today we have a special guest. We have Jamie Wilms, the Director of Education for the Molly Brown House Museum. If you don't know who Molly Brown was, keep watching. We'll have Jamie on in about half an hour.
Molly was legendary, that's for sure. Okay, here's the straight scoop. We prefer to get your phone calls. We like to talk directly with you. However, we know that some of you prefer to communicate using the internet. So we do have somebody monitoring social media. Caitlin, why don't you tell us a little bit about yourself?
Hi guys, I'm Caitlin. I'm an intern at DPS TV. As Sam mentioned, I get in all these questions that you guys ask from your homework. I grab these questions and I get them to Nathan, Becca, and Sam. And every show we have a trivia question, and I'll say it at the beginning of the show. And if you guys know the answer to this question, you can call on in, and you guys will win a prize if you get it right. And you guys can always guess. So today's question is, this is a history question. The final link of the first transcontinental railroad across the United States was completed in which state?
Okay, the final link.
I know this one. And I know a guy who worked at the location where it happened.
Oh, wow.
Of course you know it.
Well, it's just, I mean, it's yeah.
Sam, just so it's out there, last week we had a couple of science questions
Yes.
for trivia.
Really?
And we actually thought that you were faking sick so you could call in.
People called
prize.
in science questions?
No, it was
No,
a
the
trivia
trivia
question.
Oh, the
Questions.
trivia question.
Or science.
We thought you were trying to take a day off and
Just so I can win the prize. You know I'm gunning for those symphony tickets.
Okay, so
Yeah.
so here's what it was. I wonder if you know it. What is a bryologist?
Ooh, I don't know.
Ooh,
What is a bryologist?
stumped him. What wasn't it? The
Studies
study
moss.
of moss, or
Different
somebody who
mosses.
studies
Oh,
moss.
study
Sorry,
of moths or
and warts.
a moth
Like
specialist.
St. John's wort.
a moss specialist.
Oh, a moss. M-O-S-S.
Moss,
Yes,
yeah.
moss.
Not
Oh.
moths.
Bryologist or bryologist.
Bryologist.
Oh, is it bryologist?
I don't know. I didn't
We
know
were
what
saying it
meant.
wrong all last week.
That's really interesting. I
It's
didn't know that.
bryologist.
It's so,
I just found out.
the cool thing about those types of things is there's a lot you can learn about Latin if you can speak a little bit of a foreign language and
Yeah.
know sort of what the root is, but it also is a little bit of a like gotcha type question because it just means person who studies this thing, right?
Right.
But yeah, I didn't know that one, so I'll add it to the old repertoire.
Well, now you know.
Now I know.
All right.
All right. Caitlin did give a. We did meet Caitlin, and Caitlin does the social media. Let's give you that information to send your questions to us on social media. So here is the information. It's Facebook at EG Homework. It's Twitter at EG Homework as well. You could text the questions to Caitlin at 970-680-3771, or you could email us at homework@emilygriffith.edu. So we do prefer your calls, though. Call us. We like to talk to you. But you could do those as well. So let's go back to Caitlin and get some of your questions answered.
All right, today's question is a math question. This is talking about a triangle. It says, in triangle A, B, and C, the measure of angle B is 90 degrees, BC equals 16, and AC equals 20. Triangle DEF is similar to triangle ABC. Which vertices DEF correspond to vertices ABC respectively, and each side of the triangle DEF is one third of the length of the corresponding side of the triangle ABC. What is the value of sine F? I think Sam.
Yeah, Sam's got this one. This sounds like a.
Just kidding.
Was it
Think
sine cosine
for
tangent?
biologists.
I can do it. Trey, you want me to do this one? I just don't have a fancy board like you guys.
Yeah, that's true.
We could
Just
test
talk
your
it out.
skills. You seem to know a
could
lot of
indeed.
knowledge.
All right, I can take that one. So this is a trigonometry question, and it's got some similar triangles in there. So what we're first going to do is I actually copied this onto my screen, and the reason why I did is because it is a lot of text, and it can be a little intimidating at first. We do this in geometry a lot, where we give all this information kind of in written form, and if you don't draw it out, it's kind of hard to manage. So I'm going to draw this out, and I'm going to do triangle ABC right here. And I'm going to point out that it says the measure of angle B is 90 degrees. So right off the bat, we know it is a right triangle. So I want to draw something that looks like a right triangle. So here we got triangle. Nope. Fix it a little bit. So the other thing you want to be careful about, that is not any better. All right, somehow it got worse. Try one more time. One thing we want to be really careful about these is when you are given information, for example, that the measure of angle B is 90 degrees, that's really important in these similar triangle problems and trigonometry problems. So we want to, as we're kind of drawing this, I like to sketch a triangle and then label my important angles. So what I'm going to do is I'm going to call this B because it's 90 degrees. And we want to really make sure we get that, because if we don't, if we call it angle A, something like that, then we're going to end up getting the wrong answer after we do all this work. So it's triangle ABC. That's really the only angle given to you, so we don't really care about the other two. I'm going to call this AC. You could have flipped it around and called it the other way if you wanted to. Then we want to keep going through this information, and we have BC is 16. So I'm going to come over here, and I'm going to find BC is 16. And then, like I'm always writing really small now. Write that a little bit bigger, 16. And then we have other information that says AC equals 20. So AC, and I'm kind of noting as I do this that AC right here, oh, it was 20, is the hypotenuse. So it's kind of just sticking in my head as I work this out, especially because we know that this is going to have some trigonometry in the end. So triangle DEF is similar. Well, it says triangle DEF is similar to triangle ABC, and vertices DE and F correspond, which means kind of that they're in the same spot, or they kind of align with it, to vertices A, B, and C respectively. And what we mean by respectively is that you notice the order D, E, and F, and the other order is A, B, and C, so we know D and A need to be in the same spot, we know E and B need to be in the same spot, and we know F and C need to be in the same spot. So when you hear respectively, think the orders are important there. All right, so I'm going to draw another triangle. I'm going to take a look at this really quick and notice that it says, and each side of the triangle DEF is 1/3 the length of the corresponding. So the only reason I quickly noted that is I should draw my triangle smaller. Scale is, it's not super important that you get the scale right, but it helps to have at least, one should be bigger, one should be smaller. Otherwise, it can get a little confusing. I'll do this one in green. And this right here is going to be triangle DEF. All right. And again, we noticed that angle B was my right angle here. I'm going to highlight that. And we said angle E corresponds to that. So I do have to be careful and make sure that I call this angle E. And where I have angle D here, or sorry, where I have angle A, I'm going to also have angle D. So I'm going to put a D up here, and then we're just left with F. All right. Now we know each side of the triangle is 1/3 the length of the corresponding triangle. So we could figure this out by saying the length of EF has to equal 1/3 of BC, right? These are corresponding, so BC and EF are in the same spot. So here's what we're going to say with that. EF is equal to 1/3 of 16, right? Because that's the length of BC. So I'm left with 16 thirds. This is kind of a rough problem. So
Really
I'm hoping
is.
that you're okay with the trigonometry parts of it, and that maybe you're struggling a little bit with the fractions, and maybe the fact that we're adding a couple of concepts together. But this isn't going to work out necessarily nicely, but it'll work out. So we also know that 20 right here, this corresponds with DF, and so we're going to say DF equals 1/3 of 20.
Yeah, these are not nice numbers at all. They could have been
No.
a little bit nicer.
I know, your teacher's kind of mean. But it works, and so actually we're going to have some fraction dividing in here.
Oh, lovely.
We
I
are
love that
also actually going to have some Pythagorean theorem with
fractions.
it. So that's great. You know, there actually, now that I look at it, there is a shortcut to this. Like I can quickly identify, so let me get to that in a second. So we are looking for the value of sine f. Right, so here's f. If you remember, everybody always seems to remember this. SOHCAHTOA.
SOHCAHTOA.
I'm not going to go through all of these, but this is kind of just a quick way to remember the relationship. So with the SO here, we have the S for sine. And then we have the sine of whatever angle it is. I'll put a little theta here, equals opposite over the hypotenuse. So here's what we're looking for. We're going to try to say we are looking for the sine of f. That's going to equal the opposite side over the hypotenuse. And this is something that a lot of students get mixed up. When we say opposite, we're referring to opposite of angle f, right? So we're actually talking about the side directly across from it. So in this case, we're saying sine of f equals the length of DE over my hypotenuse, which is right here, over 20/3. 20 over 3. So again, you're kind of seeing that we're going to be doing some division of fractions here. Okay, now in order to do this, though, we need to first figure out what is the length of DE. And so you should be thinking, you should be kind of sad about the fact that you have to do Pythagorean theorem with these fractions, to be honest.
You should be sad.
I would be. I have a shortcut in my head that would work out pretty well because I notice the numbers 16 and 20 and think about my Pythagorean triples.
Right.
So your teacher might tell you about Pythagorean triples. You should memorize them. It will save you a lot of time.
Yeah.
Because if you're already comfortable,
Good example.
yeah, if you're already comfortable with Pythagorean theorem, you don't have to keep doing it when these numbers come out like this. So I'm going to tell you, based on what I know, that this should be, actually maybe this won't work. Let's see if it does. 9 over 3. And the reason is because I know that this should be 9. This is a 3, 4, 5 triangle that's kind of scaled up a little bit. But let's see if that actually works because it's got a fraction in it. So what we're going to do, if you don't know the triples, we're going to do 16 over 3 squared plus, and if I didn't know this side that I just told you is probably 9/3, which would just be 3. So actually that's not going to work. All right, so we're going to have to do this anyways. Right, because 9 over 3 is just 3. Yeah. So, where was I? Okay, so we're going to do plus b squared equals 20 over 3 squared. And then I'm going to do 16 squared over, so this is 256 over 9 plus b squared equals 400 over 9. And I'm just kind of working through this to solve for b. So here's what I have now. I got to subtract from both sides. So minus 256 over 9, minus 256 over 9. B squared equals 144 over 9. And then we do the square root of each side.
At least they're perfect squares.
They are, yeah. So I got b equals 12 over 3. Oh, that would have worked. I just did it wrong in my head for some reason. So this is 12 over 3. If you kind of want to know how that works, and this is not 9 over here, this is also 12. If you do know the Pythagorean triples, it could like take too much more time. One of the triangles is a 3, 4, 5 triangle. So if you notice any multiple of these numbers, as long as you use the same multiple, is going to give you that. So what I was thinking in my head was, oh, I did that backwards, didn't I? Should be like this. 3, 4, 5. What we're actually doing is multiplying it all by 4, so we're scaling it up by a factor of 4.
Scaling it up, yeah.
So if you were comfortable with that, you could have just quickly said it's 12 over 3, 16 over 3, 20 over 3. So anyway, we're doing sine of f still with all these fractions equals 12 over, nope, that's a 13. Opposite, 12 over 3 divided by 20 over 3. And a couple ways to divide this, but the way you probably know is to multiply this by the reciprocal. These cancel out, and I get 12 over 20, which simplifies to 3 over 5. All right. So again, I could have cut out a large portion of this right here if I knew Pythagorean triples.
You could also do the Pythagorean with the 20 and the 16 and then do a third rather than having to do it with the fractions.
Yeah, so that's another good way to do it. There's always a couple. But if you don't like fractions, and honestly, I hate when people say they hate fractions, but I avoid them when I can because it's just a lot of room to make a mistake.
It's more,
right?
yeah, it is. It's more work.
So you always want to try to simplify it in a way that you can avoid fractions if you can.
I don't think will have trouble convincing students to do that.
No, it's just you also have to know how to simplify them, and that's
That's
true. All right, well, that was a lengthy question. That was a tough one.
Yeah.
Nice job, mate.
Yeah.
All right, let's switch gears and go to a science question. Caitlin, do we have any?
Yeah, we have this question. If a musical note has a frequency of 440 hertz, what does that mean?
Yeah, I have a few things I can say about this. So, let's see where to start. So, I guess I'll start with what sound is, right? So a musical note is a form of sound, specific form of sound, and sound in general, as we experience it, is pressure waves moving through the air. So, for example, right now I'm talking, and my vocal cords are helping to create those pressure waves, and I'm literally sending waves through the air in front of me that reach my microphone, and then eventually your ear. But that's what sound is. It's these pressure waves traveling through the air, and if we understand sort of the form that the waves take, we can think a little bit about what frequency really is. So if we could jump to my screen really fast. This is a basic diagram of a wave. It shows sort of the idea of oscillation. Waves go back and forth. In the case of pressure waves, they go back and forth between being high pressure and low pressure. So we can imagine this diagram as it goes up, we reach the point of highest pressure, and as it comes down, we reach the point of lowest pressure. So in any case, we represent waves with this pattern. We represent waves this way, whether we're talking about sound waves or we could be talking about ocean waves, we could be talking about light waves. But the important things to see here are that there's a couple parts of the wave. So we define the wavelength as the distance from a point on a wave to the point on that same point on the next wave in the sequence. So for example, the top of this wave crest to the top of this next wave crest. That's the distance of the wavelength. We could also say from the beginning of this wave to the end of the wave, and then you can see there's another entire wave cycle right here. So there's 2 full wave cycles shown in this diagram. So the question had asked, what does 440 hertz mean? Well, so 440 hertz is a musical note. It's actually a famous musical note. It's the note A. I mean, it's often used for tuning. People will say, oh, tune to 440A. But what 440 hertz means is that there are 440 cycles of the wave, of that particular note, wave, per second. So a hertz, a single hertz would be 1 cycle or 1 wave per second. In my diagram that you can see here, we've got 2 waves shown in the diagram. And you can see above that it says the time for this would have been 1 second. So since there's 2 waves that occupy the space of 1 second, this wave would have a frequency of 2 hertz. Again, going back to our example, 440 hertz is going to be 440 waves per second. So if we look at this diagram, this also just shows like several different frequencies. These are actually all A notes. So we have a low A, 110 hertz, and then a slightly higher A, 220 hertz, and then 440, and then 880 hertz. So as we increase in hertz, where we're increasing in frequency, what you should notice about the different waves is they get bunched together more. That wavelength that I talked about a minute ago gets reduced. So the higher the frequency of a wave, the shorter the wavelength of that wave. And the idea here goes that all sounds, whether it's a low A note or a high A note, whether it's my voice or Becca's voice, they all travel, all these sounds travel at the same speed, meaning that they move forward in space at the same rate. But in the case of a wave like this 880 hertz wave, you get more wave cycles per second of time moving forward than you would with this 110 hertz wave. So that's sort of the distinction there. Briefly, I just wanted to make a plug for this interactive simulation. There's a really great website maintained by the University of Colorado called PhET Simulations. And there's tons of interactive online simulations to learn about different things through science. I use this with my physics students when we studied waves recently.
Who made it?
Who made this?
We made it.
You made it.
We did. With the fish.
With the fish.
Yeah, we did that.
Yeah. So yes, there was another thing we did, was where we made waves on a string using Swedish fish and skewers and duct tape. And if you're interested in checking that out, I don't know what the date of that show would have been, but I'll ask Nancy, our producer, to maybe put it in the comments on one of the videos we post. But in any case, you can go back and check us out doing that in a science experiment. But this simulation, if you can't build a full-on fish wave machine, this would be a good way to do it. So what am I trying to do here? Oh, loop, no end. So this is kind of a neat interactive simulator because you can just sort of see what waves look like. These are waves being produced on a string. So you could make waves like this if you just agitated the end of a rope. But all of these waves, all of these mechanical waves, even though sound waves might look different than waves traveling on a string, they share similar properties, and we can understand how they all work by understanding the properties of just one of these kinds of waves. So if we remove all the damping from this wave, we get these perfect, pure, what are called sine waves because of their shape. And you see we've got a little frequency bar down here. So if you're curious about like what is frequency, well, so I can lower the frequency to exactly 1 hertz. 1 hertz would mean that in every second we have 1 wave cycle moving forward. right? Just as I talked about before. We can up that to, what can we get here? I guess we can only go up to about 3 hertz. But there I'm at 3 hertz, so in this case, we're producing 3 wave cycles per second. And as I mentioned, one of the other things that you'll be able to notice here is, even though we're producing more waves per second here, the individual wave motion, like the movement of this crest, is not any faster, even though the frequency is higher. If I were to lower the frequency back down, and we were to look at this wave, even though this wave looks much slower, the movement of the energy through the medium actually is occurring at the exact same rate as it was in the higher frequency wave. So anyways, this is just kind of a cool simulation you can use to do that. You can add in rulers and a timer to do different things, kind of neat. So I'll wrap it up there, but yeah, the answer to the question, 440 waves per second.
That's a really cool interactive thing.
Yeah, it's
I'm gonna
useful.
use that when I
It really
teach.
is,
It helped my
trigonometry.
students a lot to understand it. It's kind of a nice way to learn in addition to all the examples we were seeing in the
Yeah.
sound wave.
No, absolutely. I think that's really great. All right, well, we're going to take a little bit of a break from answering your questions, and when we come back from the break, we will be with Jamie Wilms from the Molly Brown House. So we'll see you soon. Hi, welcome back. We are here with Jamie Wilms from the Molly Brown House. Welcome to the show.
Thank you. Thanks for having me here.
Yeah. So I have a story I'm going to start this out with. I was in a Lyft the other day. It was a ride share, and there were tourists in the ride share with me, and they asked the Lyft driver, they said, where's one place that we should visit in Denver? And they said the Molly Brown House. The Lyft driver just said, you have to go to the Molly Brown House, you have to go. And so it kind of piqued my interest.
Awesome.
And thought, oh great, we're having you on the show, that's perfect, get to hear about it. So what is your job title and your role at Molly Brown House, first off?
So at the Molly Brown House Museum, I am Director of Education. So I work with all the children that come through the doors or the outreach programs that we do in the schools. Every single teacher that calls, I talk to them. I'm also in charge of evaluation at the museum, different visitor engagements and other things like that too. So if it's dealing with people, you're dealing with me. So, yeah.
Gotcha, okay.
And can you tell us, I understand that some people didn't know who Molly Brown was.
I was going to say, yeah, we just
Should I be
Can
pointing
somebody-
They
fingers?
didn't understand who Molly Brown was?
Some people I've heard,
What's the
don't
general
know.
history? Because there's got to be somebody watching that might not.
I'm sure.
Yeah, tell us
So-
about Molly Brown.
First off, we call her Margaret. She was never called Molly in her
Okay.
lifetime, so I'll be calling her Margaret from now on. I'll talk more about that later, why she got that name. She is most famous for surviving the Titanic.
Yes.
She became known as the unsinkable Molly Brown, a nickname given to her later in life. But beyond surviving the Titanic, she did a lot here in Colorado, over on the East Coast, and also in France as well during World War I. She fought for women's suffrage, she fought for minors' rights, she formed the first juvenile justice system for children here in Denver as well that became a model for other cities. So she helped fundraise to build cathedrals, she cared about our pets here in Denver. So she drove ambulances in World War I. I mean, that's just the tip of the iceberg. So, tip of the iceberg. Got it.
Well, we love puns here.
So she was more than just Titanic, but that's what she's most known for.
Right.
Yep.
What was the exact story with the Titanic? Because I vaguely have heard, but wasn't she an advocate for saving more people at the time?
She did advocate to go with her lifeboat to go back and get more people.
Right.
Her big thing was that, of course, we all know on Titanic, it was women and children first. She hated this idea because you're splitting up a family. At this point in time, the husband is the breadwinner. He's bringing home the bacon, as we say. So these wives, mothers, they're losing their source of income because, of course, we as women weren't working much back then. So she wanted to keep families together. But after Titanic on Carpathia, she spoke 5 other languages. She was able to help the third-class passengers who were immigrants, help calm them down, raise money for them and stuff like that. So she was working for everybody that was on board that ship.
That's amazing.
Wow, she sounded like a really, really cool person.
I would be friends with her.
Totally, yes. Yeah,
I would
totally.
we'd be besties, I think. So yeah.
Yeah, sounds like a really great person. How did she, so she got rich, and that's really why she had the means to do all of the things that she did. Is that correct?
Correct. She is originally from Hannibal, Missouri. She came out to Colorado, to Leadville specifically, when she was 18 years old. And that's where she met her husband, JJ. At that time, he wasn't a rich man, but in 1893, after the Sherman-Silver Repeal Act, he actually found a new way to hold up the mine walls, and he found the largest vein of gold in North America. So that's how they got their money, and that's when they moved down to Denver. She was able to use that money and influence to help all these people and all of her causes as well. Even before they had the money in Leadville, she was helping miners up there. She did soup kitchens and other things. So this was always in her nature to help people, even before they became millionaires.
Not just because of the money just gave her more means to,
Exactly.
to help out.
Yep.
Okay.
Was
Makes
she
a lot
just
of sense.
a general advocate during the suffrage movement, or was there anything specific that she did as part of that movement?
She gave, out in Newport, Rhode Island, she actually spoke during the Conference of Great Women, advocating for us women to have the vote. Colorado actually gave women, a lot of people don't know this, women the right to vote in 1893. We as women nationally didn't get it till 1920. But here in Colorado, we could only vote in local elections. But Margaret fought hard for that national amendment. You may have heard of Ava Belmont and Alice Paul and other big names like that. She worked with all of them. But she was mainly working on the East Coast for that national push. And eventually, obviously, we got it. So it's a good thing.
Yeah.
So, go ahead.
Oh, can you tell us a little bit about opportunities for students and teachers? And you have field trips there, and
We have
of that nature.
lots of opportunities. Our two on-site programs, we have a house tour that will take you through the house, and you'll learn not only the history of the house and the objects inside and everything like that, but you'll learn Margaret's story and her impact on Denver, Colorado, and the world. We also have a walking tour, which we put in a couple years ago, that takes you around her neighborhood in the Capitol Hill neighborhood. And you get to see some buildings she helped influence, including the Cathedral of the Immaculate Conception, the state capitol. You learn about when that was built and stuff like that as well. That tour shows you a great example of urban growth and how cities preserve their historic structures while putting in new ones. So it's that nice blend of old and new within that tour. For our outreach programs, we have a ton of outreach programs that cover everything from the history of Colorado and Denver to historic preservation. And then two of our newer ones, A Doughboy's Life, which is one of my new favorite ones. Margaret's son, Larry, actually served in World War I. And he was on the Hindenburg Line. He got sprayed with mustard gas. This program takes you through what it was like to be recruited, to enlist, to go through basic training, what it was like to be a soldier during World War I. But we also tie in Margaret's efforts. After the war, she actually had all of Mark Twain's works translated into Braille, so that soldiers who lost their eyesight during the war could still read. And our other one, Women in Colorado from Pioneers to Engineers, takes a look at female contributions in Colorado, not just what Margaret did. It's kind of fun how we did that program. Margaret becomes a time traveler. And she goes back in time and she has conversations with all these women to see their influences on Colorado. Those are just a few that we have. We have several more.
that's cool. We actually have
that's
a
really
picture of her up on my screen if you want to take a look. And I believe the hat that you brought is a replica of the one that she's wearing up here.
It's very similar to what you see on there. That photograph is actually with Captain Rostron, who is the captain of the Carpathia, the rescue ship from Titanic. This was taken in May of 1912. It was a ceremony to thank the captain and all of his crew members for picking them up that night. And what you see Captain Rostron holding is called a loving cup. It's kind of like a trophy type thing, giving an honor of them. And Margaret and several others were there on hand to present that to him. She was also in charge of the Titanic Survivors Committee, which she and other passengers started on Carpathia. And on the decks of Carpathia itself, she raised $10,000 before they got to New York City. And all that money went back to the survivors.
Oh, wow.
Wow.
And she was, in this picture, she's 44 years old. So she's still fairly young at that time. When she was on Titanic, she did sail alone. And she actually was never supposed to be on the ship. She was traveling in Europe with her daughter Helen and JJ and Madeline Astor, which a lot of people know that name. She got a telegram from her son Larry saying that her one and only grandson was ill. So that's the only reason that she got back on Titanic.
Wow.
Oh, wow. No, I just want to hear more. I'm just
Oh, I could stay here all afternoon and tell you everything.
Storytelling. Tell me.
Yep.
Tell me more.
What part of town is the Molly Brown house in, and was that the house that she lived in while she lived in Denver?
So we're in the what is called the Capitol Hill neighborhood. We're 2 or 3 blocks from the state capitol on Pennsylvania, between 13th and 14th.
That's right near me.
You
So
can come
back.
see us anytime. This house was built in 1889. The Browns were not the first owners of it. They purchased it in 1894. It's in its exact same location, the exact same lot size as they had it in the late 19th century.
Is all the furniture in it her furniture? And
Unfortunately not. Probably about 25% of our pieces did belong to the Browns. There still are descendants out there of the Brown family, so they have some of those pieces, and some are in other museums across the country as well.
I see. Gotta share the love.
God, I don't want to, but we have to. So
Yeah.
Do you know anything about the Molly Brown summer house?
that is privately owned,
Okay.
but that was their home. JJ had that built in the late 1890s, and it's kind of funny to hear it say summer house because it's out on Wadsworth and Yale.
Right.
And for
Oh,
me,
that's just down the street from me, actually.
That's right down the street from me too. It's like a 20-minute drive from here, but back
Yeah.
then it was a half-day carriage ride to get out there.
Oh, yeah. When I think summer house, I think like
Somewhere
yeah.
far, right? Yeah.
Yeah.
Well, yeah, half day trip. That would be
Too far.
Oh, I know. I just,
Somewhere.
I drive there every day,
Yep.
obviously. So,
summer house.
like, I'm going to go to my summer home and relax for 3 months.
Just on the
Yeah.
other side.
Drive,
I have my summer home
20
in
minutes.
Arvada. That's where I summer.
But their summer house was a full working farm and everything too.
Wow.
So yeah.
Very cool.
But they didn't own it very long, and the family that owns it now are descendants of the people who bought it from the Browns. So it's only been in two families' hands.
Right.
So,
Gotta
which is
hold on
kinda
to it.
cool. Yeah.
That's cool.
She sounds like such a neat person. And there was a movie and a play also about her. Is that
There
right?
was, yes. There was it started as a musical, The Unsinkable Molly Brown. There are very few things in that is factual,
Oh,
unfortunately.
that's kind of
I'm sorry.
unfortunate. Because there's so many cool factual things about her. You would think that.
Yeah, you're going right where my brain is thinking. Her life was so extraordinary. Actually, in 1932, after her death, there was a book written called Timberline by Gene Fowler, and he took her events of her life and over-exaggerated this. And this was the basis for the musical and the movie Unsinkable Molly Brown.
Okay.
But Hollywood took it, especially the one with Debbie Reynolds, took it and just over-exaggerated it even more. Margaret was a very well-educated woman. She had education to the 8th grade. Like I said, she spoke 5 languages. She was accepted into society. She was not born in the river. So you have to take that movie with a grain of salt. But with that movie coming out in the 1960s, Margaret's house was almost torn down during that same decade. With the popularity of that movie, it helped save that house because her name became more well known. So it was really nice that kind of correlated together to help save her house, which is awesome.
When you said you were going to mention earlier, why was she called Molly Brown?
Oh,
even though she
yes,
was technically
yes.
Margaret?
So when the musical was written, Meredith Willson, who wrote the lyrics for that musical, he found it too hard to sing Margaret. So he changed her name to Molly. And she's been known as that ever since. But if I came here and I told you, I'm from the Margaret Tobin Brown House Museum, would you have any idea who we're talking about?
I would not.
So,
You did it anyways.
so
Irrelevant.
we pull you in with that Molly, and we tell you
Sure.
the true story of Margaret.
That's really cool.
Which is much more fascinating than
Right.
Yeah.
anything Hollywood could ever come up with.
Yeah.
That's very true. So if you want real information on Molly Brown, you need to visit the house. Or do you have any other resources that you suggest that if you want real biographical information about Molly Brown or Margaret Brown?
Oh, I like that you changed your name there. There is a book called Unraveling the Myth. It's written by Dr. Kristen Iverson, which is the most up-to-date biography on Margaret. The awesome thing is that History Colorado's archives, back when Larry, her son, passed away, because we didn't exist yet, he donated all of her things to History Colorado. So they have that in their archives. And also, Denver Public Library in their Western History section has some great photographs and stuff in there too. So, but if you're looking for a book, Unraveling the Myth is the best one to go for.
Unraveling the Myth. Okay. Cool. Good to know. Do you also do field trips? Is that right?
Yes, we have them on site. We do house tours and walking tours at the museum.
Oh,
Yep.
okay. You did
Yep.
talk about the
Yep.
field trips, the
Yep.
house tours and field trips. And do you do anything in the schools?
The 2 outreach programs I talked about before, the Doughboys Life and Women in Colorado, those are
Those are in
outreach.
schools.
Yep.
Okay.
We have
Sorry.
about a dozen outreach programs total. They're varying depending on the age of the student and the grade. depends on which program you'd pick. Our most popular one is called Denver Grows, which is great for 3rd and 4th grade curriculum because it covers local history, Colorado history. But we have another one called Lego City that actually teaches kids about historic preservation through building an 1850s town out of Lincoln logs. Then we fast forward 100 years to the 1950s, and you build a modern town out of Legos.
That
And
sounds
then you
awesome.
have to
That sounds very awesome.
That's
I
like
can
my
bring it in
dream as a
here.
10-year-old.
Right.
That'd be amazing.
You have to decide which ones historic structures you want to keep. And these kids get into such heated debates. I've had kids yell at each other because they wanted to keep this building over that building. And it gets very intense, but it helps them understand the importance of historic preservation.
That's really cool.
Yeah.
That is super cool.
And
Yeah.
plus, I get to play with Legos.
Yeah.
Right.
Who else gets to say that in their
Yeah,
day job? So.
So cool. That's a great idea too. All right. Well, I think we're about out of time for it. But guys, if you the Molly Brown House is right downtown. It's right in Denver, really close to where we are. So if you want more information and just want to check out all of the cool stuff that we learned about today from Jamie, thank you so much.
Sure thing.
Be sure to visit the Molly Brown House. There's also the link to the website on your screen right now. So thank you so much, Jamie, for visiting us and telling us all about the Margaret Brown House. We really do appreciate learning a lot about it. Thanks
Awesome.
for coming.
Well, thanks for having me today.
Thank
I
you.
enjoyed it a lot.
Yeah.
Welcome back. Hope you guys enjoyed hearing about Margaret Brown. That was something I learned today. I didn't realize that her name was not Molly, or that she didn't go
Me
by
either.
that.
Yeah.
But hope you guys learned something. Let's give you guys our contact information real quick, just in case you're just joining us. That way you can send your questions in to us, and we can help you with your homework. So phone number is always on the top of your screen, but you can send your questions in to us at social media at Facebook or Twitter at EG Homework. You can text us the questions, at 970-680-3771, or you could email us at homework@emilygriffith.edu. So you can get your questions answered. I think we should also possibly get the trivia question one more time as well. Caitlin, could you give us that trivia question one more time, just so that we could have some winners maybe?
Yeah. Today's trivia question is, the final link of the first transcontinental railroad across the United States was completed in which state?
All right. Don't give it away, Sam.
Oh.
All right. Let's go back. Let's get some more of your questions answered. Let's see what we have waiting for us.
All right, we have a math question next. It's asking to solve for x for this equation.
Alrighty, just hold that up there for just 1 second, and I will write that down, and we can solve for it. Oops, gosh. I have to apologize. I'm a little bit tired today. My brain's a little bit slow for some reason. Okay. 2x minus 4 equals -18. I think I got it right. All right, I can help you out here. So this is a basic, it's a linear equation. I've shown how to solve these with algebra tiles at some point. I could do that again today, but this one's a little bit more complicated one, so I'm going to avoid that. I'm just going to talk about maybe some key things to remember when you're solving equations. The one thing that you want to remember first off is that your goal is to isolate x. Or the variable. In this case, it's x. But isolate your variable, meaning get it by itself. A lot of times to do this, we need to simplify. So I would say to simplify, we would apply the distributive property. And I'll show you what that is in just a second. And then combine like terms. Also helps us out. Combine like terms. And then lastly, so if you do those two things, maybe the last little step that I could maybe generalize to solving equations is to use inverse operations or undo. You can think of undo to isolate x. So if it's x minus 3, I'm going to add 3 to both sides to isolate it, so undoing what's happening. So the first part that I talked about was the distributive property. That is when, that looks like this. There's kind of an example of our distributive property. And what this is saying is, or what the parentheses are doing is they're grouping. They're saying that I'm going to take 2 times both of the things that are in parentheses here. So 2 times the x and 2 times the 7. So I'm going to multiply these two together first. So 2 times x gives us 2x. 2 times the 7 gives us 14. The same is going to apply over here. You see another distributive property over here. This time I'm going to think of it as a -3 times 2x and -3 times -4. So -3 times 2x is going to give us -6x, and the -3 times -4 is going to give us a +12. Over on the right side of this equation, we haven't touched anything yet, so we're going to rewrite it and call it -18 still. So that's my distributive property. Check. Got that done. Now if there are any like terms, I want to combine them. Like terms are terms that have the same variable and same power. So if you notice here, I have +2x and I have -6x. Those have the same variable. So these are like terms. 14 and 12 would not be like terms with 2x and -6x, so we wouldn't put them together. So I got my 2x and -6x. I'm going to combine those together. Those give us -4x. Then I need to combine my 14 and my 12 together. Those are also like terms, these two. So 14 and 12 together, that's going to give me 26. So I've got -4x plus 26 equals -18. So I've got my like terms, combine them. I've got a much simpler equation than when I started, so now I'm going to be able to start inversing and undoing. So you notice my variable here, this x, he's got some multiplication. He's being multiplied by -4, and 26 is being added to it. So we're going to inverse those by subtracting 26 from both sides to start with. And that gets rid of that, and I have -4x. And then over here, I have -44. From there, I just need to have one more step to undo. I've got some multiplication that I'm undoing, so I'm going to undo it by dividing by -4 on both sides. On the left, my -4 divided by -4 just gives me 1, so that goes away. And then on the right, I have -44 divided by -4, and that gives me a +11. I could also go back and check this problem by replacing my x in the original problem with 11 and making sure that both sides were equal. Because of time, I'm not going to do that, but you should always get in the habit of doing that when you're solving these equations, especially if they're multiple step like these are, just to make sure that nothing went wrong along the way. So hopefully that helps a little bit. I have got a bunch of different ways to show, but this is one of the ones that, one of the methods, I guess, you could go by. So hopefully that helps.
Yeah. It sounds like we have time for one more science question. If we want to go to that.
Okay.
All right. Our science question is, why do we put salt on sidewalks when it snows?
Yeah. We put salt on sidewalks when it snows because we want to raise the freezing point of ice or of water. If we could jump to my screen really quickly. There's just a fancy picture of somebody pouring ice on the sidewalk because I thought you needed to see that. But this is the picture I really wanted to show you. So the reason that putting salt on ice raises the freezing point and allows essentially allows the ice to melt more easily is because salt, the salt that we're typically using here is sodium chloride. So sodium chloride is composed of sodium ions and chlorine ions, and when salt dissolves in water, it dissociates into positive sodium ions and negative chlorine ions. And these dissolved compounds inside of the water essentially make it harder for water molecules to join together and freeze into ice crystals. So, if you have a day where it's kind of maybe right around freezing temperature, or maybe just above, and you want the snow to be melting more quickly, or the ice on your sidewalk to be melting more quickly, when you sprinkle that layer of salt onto the ice, some of that salt will begin to dissolve in the layer of the very thin layer of water that's sort of on top of that ice, and that process will make it harder for any of that water to refreeze later. So it just essentially accelerates the melting process. So that's about all I can say about that. But maybe we just needed a quick one.
Yeah, that's interesting though, because that it actually raises. You said raises the freezing point, or
Yep.
Yeah, I thought it was actually somehow warmed it.
Yeah, some people will argue that the process of the dissolving actually releases heat, and that does some of it, but
Okay.
that's largely not true. It seems like the main mechanism is the salt molecules or the salt ions essentially get in the way of a water molecule refreezing to other water molecules. Just the concentration of water molecules is lower, there's salt getting in the way, and then that means that all the pure water that's ice down below can be melting, while melted water is unable to refreeze.
Okay.
Does that sort of make sense?
Yeah,
That's
yeah,
essentially the
interesting.
process.
I was going to ask if altitude has anything to do with it. Do you have a quick answer for that?
Altitude does affect boiling points and freezing
Yeah.
points. The specific, though, I'm not exactly
I've
sure.
just noticed the difference between winters here and winters on the flatlands.
Yeah, so basically at lower elevations, stuff should melt faster because there's more air pressure, and so molecules should move faster, and so things should heat up quicker.
Yeah.
I think
That
that's
makes.
the
I
case.
mean,
I think that's
that
the case.
answers my question.
Yeah.
Okay.
It does. It answers my question. Okay. I don't know. Do we have time for more?
No, I think we should
Trivia
probably,
question?
hop
Okay.
over
No more
to
time
trivia.
for more. We should probably talk about the trivia question then. Caitlin.
All right, the trivia question is, once again, the final link of the first transcontinental railroad across the United States was completed in which state? And the answer is Utah.
Utah. Well, it had to be in the middle somewhere, right?
Yeah.
Right.
Is that what your guess was? Or
Yeah, because it's at a specific park called Golden Spike National Park or National
Oh, okay.
Monument. I can't remember, but they finished the railroad with a golden spike. Like the last spike that they sunk was golden, and then now today there's I can't remember again whether it's a monument or a historic site or whatever, but it's run by the Department of the Interior. And I work with a guy at Carlsbad Caverns National Park. We were park rangers together, and he got a permanent job at Golden Spike. It's way up in northern Utah, kind of out of the.
Is there anything else around there other than that?
It's like the north side of the Great Salt Lake in my memory. That's what I remember it being. It's not too far from Salt Lake City, but it's also not like really close.
Okay.
Also, it's not near the cool part of Utah, which to me is everything south of I-70. Like that's where I would spend my time. So I wasn't like jealous of him, but I did learn the answer to that trivia question.
Nice.
The things you learn, right?
The things you learn.
What else do you know, Caitlin? What do you know about this?
Well, on May 10th of 1969, the last railroad spike was driven into the ground of Promontory Summit in Utah. A ceremony was held to commemorate the event, and the golden spike was known as the last spike driven in the ground. And it was a very huge event at its time, so that's really great.
Huge deal. It seems like such a not big deal today to be able to travel transcontinentally, but at the time that was the first consistent transcontinental pathway.
This route apparently followed a couple trails, one of them the Oregon Trail, which I know very well.
Oh, it did?
From the
Played
computer
the
game.
Oregon Trail.
Oh, of course,
High
yeah.
chance of dysentery.
Oh, yeah.
I was bit by several snakes, but it was good experience.
Good experience.
Yeah, I'm great at hunting for digital rabbits.
Yeah. And awesome.
All right. Well, I think it is about time to say goodbye today and wrap it up just for today. But we will be back tomorrow. So if you didn't get your homework questions answered today, just send them in tomorrow. Tell your teacher sorry, and we'll see you again tomorrow. Thanks.